Okay, as the same as yesterday. We have to go to new one. This is yesterday notes. This is today's notes. Okay. Networking devices we use in the networking. Of course, one is NIC. We know already. Okay. So here, few important devices we use. One is hub, switch, router, modem. Okay. So hub are a repeater. Hub are a repeater. Hub are a repeater. Bridge. Bridge is also there. So we'll see that one. And other few devices also there. Other few devices also there. But importantly, understand what is hub. Um, I didn't discuss about a topology kind of stuff, but still okay, no problem. Okay. So here it is, networking hub. What is this networking hub? It look like this one. So if you see these things, okay, networking hubs. Okay, there is a connection points are there. You can see here RJ45 connection. You can connect it to your PC. You're connected to your PC. Okay, so like these are different systems. I want to connect all these systems together so then I can communicate to these systems. How to do it? By connecting to a device. So this device can be a hub or a switch. Okay, these hubs are to make a simple LAN connection. Hub, it is used to create a simple LAN. So maximum like a only 4 to 8 devices. It means your PCs. Okay, so there is a 4 port hub, 8 port hub is there. 4 port hub, 8 port hub is there. Not a, very big hubs or very less big hubs like what we can say 16 port, 24 port, 48 port hubs. In generally, we don't use it. Okay, sometimes it is enhanced to your router kind of stuff. That is also okay. Okay, so this is a hub. Hub is a non-intelligent device. Okay, it is a not a it's not a intelligent device. Nothing, no learning and all. It is only just connecting part only. It means it's just a small circuit board and power on connection is there, and back of these things only direct connections, one to one connections are there. That's it. It is a single broadcast domain. It means if A PC, B PC, C PC, and D PC. If A want to send message to B, you want to send a message to B. So it's sending to B. the packet goes like this. Understand, guys? Packet goes like this. Packet go to the hub. Hub send a packet to B and C and D. Okay. What happened? I want to go send a packet A to B, but packet went to every other device connected to hub. Every other devices connected to your hub. For example, you want to send A to D. Okay. Now A send a packet to hub and send to B, C, and D also. Guys, understood? It broadcasts the message to every device. This is called a broadcasting. Broadcasting means one to all. So whenever the hub receive a packet and send to everyone, not wantedly because of the circuit is like that. Meaning is
Sir, it's like internal data transfer, right?
yes, internally within the your LAN network only. In your LAN network. So I have a computers, different computers are there. I connected to a hub. So what happened when you are communicating? So obviously A to B around to communicate, but it's sent to everyone. So there is a problem, right? So if it is sent to the everyone, but actually what happens? Also look at here. It is just like a letter kind of stuff. Any letter having a to address and from address, right? So A, B, C, D, and they are connected to hub. They are connected to hub. Now, first one is A want to send a packet to B. To address is B, and from address is A. But hub don't know anything. Hub don't know anything. It's not even a no intelligent device. A when it is sending to B, so through hub only. So it packet went to hub and packet went to B, and same packet went to C, same packet went to D. So B, C, D get a same packet from A, but what is the to address? B. So same C received this packet and it verify the to address, and what it will do? It drop it. D also received the same packet and verified the to address and drop it. B see the to address and verified both are same, then it is accept the packet. Okay. Even though if you are using a hub, the message won't go to message completely not accepting here because of whenever the protocol works like this to address and from address you received a some letter, the to address is not yours, so what you will do, you'll drop it in the communication in our network communication. What we will do, we'll drop it. It means we don't take it, we don't accept that packet because it's not meant for you, like that. Same example again I will explain. I want to send a message to B to D, B to D. So to address is D here. So B send a packet, packet goes to hub, and that packet go to A, C, and D also. Okay, A, C, and D. A check it. Is it packet for me? Is it to address is A? No, then it will drop the packet. And C receives and verifies. Is a packet for me? No, drop the packet. D received the packet and verified that this belongs to me. Accept the packet. So this is how it is communicates in the network. And a hub is never understand to whom packet is forwarding. So it is broadcast to everyone. Okay, it is a simply say a broadcast domain. It works in a off duplex packet. Packet loss is more often. Okay, more often means frequently packet loss is there. Okay, so here it is. If you are observe by explaining is same, but you can see I'm sending a packet A to B parallelly B to D. So for example, you're sending a packet and also you will receiving a packet means the same way you are getting something, or maybe you are getting so many things in the same way. What happened? Traffic jam. For example, here C receiving both packets from A as well as a B. She received both the packages A as well as a B. Both are invalid. Unnecessary data traffic at your system side. So that's the problem. Okay, so that is it. And whenever the packets are collide each other, packets will be damaged. Yeah, Jay Kishore, tell me. Jay Kishore, raise a hand. Guys, what is this half duplex, full duplex? Yeah. What is this half duplex, full duplex kind of stuff? We'll see. Look at here. Simplex. First one is simplex. Okay. The first one is simplex. Is like very simple. This is A, and this is the destination B. And A send a packet to B. That's it. A send a communication. They're talking. A is talking. B is listening. So A is sending. B is receiving. That's it. No other way. No other way. Okay. No reverse. No reverse talk. No reverse talk. That is called a simplex. Half duplex. What is half duplex? Same example. A
Example
sending.
walkie-talkie, sir.
Yeah, half duplex is actually walkie talkie. Okay. So half duplex is a walkie talkie. It's like A sending a message, B receiving a message. Okay. Whenever B sending a message, A receive a message, but not simultaneously. But not simultaneously. It's a two-way communication, but not simultaneously. Simultaneously, you won't talk. So when you are sending, you are in a sending mode only. Example is walkie-talkie. Yes, in a walkie-talkie, there is a button. If you want to talk, you have to press the button, then only you can able to talk. Okay, otherwise it is one way communication. So you will receive the communication from different walkie talkies or stations only. Okay, when you press the button to talk, so once you're done, you have to tell like a over and out kind of stuff. Okay, so usually like TVs they said no over kind of stuff. It means your message is over. I told my message over. You can go to the do second message. You can continue like that. Okay. So what is off duplex? It's a two-way communication, but not at same time. Now what is a full duplex?
Duplex is a normal call to talk to another person.
Very good. It is just like a two-way communication, but communication from both the sides. Just like a your telephone. Telephone communication is the best example of full way duplex. Very good. A, B is a destination. A send a message, B receive it. B send a message, A receive it. We actually say full duplex is not there. It is a two simplexes. Yeah, two-way communication. Two-way communication. So off duplex, full duplex, both are two-way communication. But in off duplex, if you are sending, you will receive it. And if you are receiving means someone is sent. Either you are send or a receive, but not at both the time. Both are not at same time. Full duplex, so you are send and as well as a receive at the same time. Actually there is no full duplex. It is a simply say two simplexes. So two simplexes, A to B one simplex, B to A another simplex. So yeah, you send a communication or you are communicating with one simplex to A to B and another simplex to B to A. Okay, two simplexes are there in a full duplex. Okay, next switch. A hub is also act like a repeater. So what is this repeater? So repeater is simple. You have a signal like you are communicating from one place to some long distance. So your cable length may not be enough. Length means the signal strength in the cable may not be enough. So normally we are using UTP cables. The maximum length is 100 meters. Okay. So what I will do, I take the cable. For example, I reach 80 to 90 meters. Okay, for just for example, and I put a hub here. Then I will run another cable from here. I connect this cable to hub and hub to outside. So what happen? I can run up to another 100 meters. Means like a 80 to 90 meters. I can use this cable again hub like that. So if length of the cable is requirement is more and then it leaded to low signal degradation. So what we have to use hub as a repeater. Navyasri present. Yeah, here it is. Navyasri present. Okay guys, so that is called a repeater. So to connect very long distance, not very long distance, long distance device. So if there is a compromise of your cable, so cable length is not enough. So what to do? You can use a hub as a repeater. Okay. Next one is switch. Next one is switch. Switch is also for a LAN purpose only. Both simple and big LANs purpose. Okay. Big network. Okay. Simple and big both are there. We can connect more devices also. Means 48 devices, 100 devices, 200 devices. Depends upon the switches and number of switches you are using. Intelligent. Intelligent device. This is the intelligent device. It know how to learn MAC address, learn MAC address, maps MAC address of PC or of device to switch port number. Switch port number. This is called a MAC address table. MAT. Okay. So what is this? Okay. Full duplex mode. Look at here. This is my switch. Here is a computer. Actually, in a networking related classes, I have to go to the packet explanation part. But I'm not doing that one now because one is a time concentration, another one is the subject become little heavy. Again, I have to explain 2 3 times. Okay, so then I'm going with a normal explanation only. Same diagram, ABCD, and this is the switch. This is the switch. So through switch, I connect like this. Okay, through switch, I connect like this. Now what will happen? Sai Kiran. Where is Sai Kiran? Here it is. Okay. So here what will happen? First of all, when I switch on my switch, so what will happen? See it is. I want to communicate from A to B. Same scenario. Packet go to switch and switch to all the all the devices. So same as a hub only. Same as a hub only. But what it will do? In a switch, it will create a table. Okay. A is sending, right? A is sending. So first A is MAC address. It will take A's MAC address. Okay. It mapping to this port number. For example, port number 1. Okay. And B is replying back to A. B is replying to back to A. So it means B to A. Now it will take B's MAC address, and to whom you are communicating, B to A, and A's MAC address already known. So then, okay, so then it will communicate it forward to A directly. Understand? Yeah, it's a little confusion. I will go back and I will explain it again. The difference between hub and switch is like this. So it is also which is look like same and same kind of connection only. But if you see, I'm trying to communicate from A to B. What happened? A is sending a packet first time. Okay, packet went to B, C, and D. Okay, so whenever switch received a packet from A, first it has to be received right like this. So what it will shows, it will put a A's MAC address and A's port number on which port they are connected. For example, port number is 1. Port number is 1. So this is called a MAC address table. Similarly, B try to communicate it to A. B is trying to communicate it to A. Next, packet go to packet go to switch. Packet going to switch and switch check it, and then it will put a big at B's MAC address. Okay, so where B is located at port number 2, and as per this table, where is A? Where is A? Port number 1. Where is A? At a port number 1. So then it is send a packet directly to A instead of broadcasting again and again. So it reduces the number of broadcasts. So then data loss is also reduced. So this is about a switch. And few more points I want to add it. So when you are saying layer wise, it is a layer 2 device. Okay, and it understand MAC address. Okay, learn the MAC address from the devices and map the device to switch port number. Hub is a layer 1 device and don't know about any MAC address or IP address. Next one is router. Okay, what is this router? Okay, router is a layer 3 device. Router can understand IP address. Understand? Why it is understand IP address. Okay, works with IP address and routing and routed protocols. Okay, so here is a routing protocols. RIP. Why it is RIP, EIGRP, ospf, bgp, is, yes, like this. These are the called routing protocols. What is routed protocols? IP address. Okay, so it is do best path selection. What it will do? It do best path selection. Okay, so best path to reach destination. Okay, so simply say how to reach destination will tell by the routers only. How to reach the destination by routers only. Okay, it is also intelligent device, layer 3 device, understand IP addresses mainly for inter networking device. It is a inter networking device. What is internet networking? Communication between two or more networks. Communication between two or more networks. And also purpose is internet purpose also use it. When purposes we can use route. There is a few more things about a router is there, so we'll see that one later. Next one is modem. Modem is another important device. Okay, modem means modem. Okay, two words, two parts. Modem, modulator, and demodulator. Okay, just like you have a FM radio. FM radio is a receiver, right? You have a FM radio. You are receiving a FM signal. So 88 or 108 or a 104, 93.7. These are a frequency setters. Okay, so when you tune to that one, you will get a certain audio kind of stuff, right? Song or kind of stuff. So you are a demodulator. You are using a demodulator. At FM station, they use a modulator. In your hand, you are using a demodulator. So what is a modulator? Add a high frequency signal. Just I'm telling line. That's it, guys. It's not a standard definition. Just for our understanding. Signal to normal signal for transmit to long distance. So that is a modulation demodulation process. Okay, but what is a modulator and demodulator? What is the modem will do? Modem converts or translates, transfers, whatever it is. The word you use it converts. Okay, our computer generating digital signals. Okay, computer digital network signals to telephone analog signals. like this. What is this modem? Modem, earlier internal modem, external modems are there. So you can try modem networking. So these are some kind of modems are there. No need to worry about, guys. If you see any thing is like your Wi-Fi routers. If you can able to see your Wi-Fi router, BSNL Wi-Fi routers, okay, Airtel Wi-Fi router kind of stuff, not other kind of stuff. Anything, one form of signal will be converted into other. Okay, usually your Airtel or BSNL will use telephone cables for a data transmission purpose. But telephone cables are a analog signal. Our computers are digital signals. So what do we do? We use a modem to make a connection to the internet through the telephone cable. Use it to connect internet through telephone cable in generally. Through telephone cable or a telephone department. Nowadays we are getting fiber optical, but still whatever the fiber optical, there is a modem inside. Modem actually make a connection. And lot of details about a modem is there for a troubleshooting also. Mm, okay. So these are the main devices we use in the networking. Yeah, tell me. These are the differences. Here it is a bridge. Bridge is not a device. Bridge is not a particular device. You have a computer and you inserted extra NICs in it, and you can make a bridge to one NIC to another NIC. So that is called a bridging. It is a bridge is like a more like a software type. Less number of ports we have. Okay. It is an intelligent device, works with logical addressing, fixed bandwidth router. So this is about a certain devices. Some devices, there are a lot of devices are there. So what are the devices? Mainly hub, switch, router, modem. Hub is a layer one device. It's a physical layer. Okay. It's a simple LAN. To create a simple LAN, you can use four or five PCs. Means lesser PCs we use it. Lesser devices. We use it to connect in a simple LAN network. Non-intelligent, not intelligent device. It is sending a broadcast. Packet loss, data loss is there. Broadcast domain. Okay, and the next instead of broadcast domain, broadcast to everyone. Broadcast to every. Broadcast to all. Off duplex mode operations. Okay, packet loss is more often acts like a repeater. So why we are using a hub? For example, I have to connect a one or two PCs or maybe a three or four PCs. Hub is a cheaper. Hub is a cheaper than a switch, but no security because it is sending to everyone. First, second is more collisions are occurring. Means more packet losses occurs. Then obviously you have to send same data again and again. So obviously the communication speed of the communication will change. That is a hub. Switch is a layer 2 device. It understands the MAC address of the PCs. It is for a simple and big network. Okay, simple LAN and big LANs also we can do it. Connect more devices. Intelligent device. It can able to learn the MAC address of the PCs. It maps the MAC address of the device to switch port number and create a MAC address table and create a MAC address table. Okay, it operates in full duplex. Reduce number of broadcasts so that data loss will be less. Next, LAN hub and switches are for a LAN purpose. Router is internet and WAN purpose also we are using. Okay, it works with routing and routed protocols, means works with RIP, AGRP, ospf type of protocols, and as well as a IP address also. Best path selection, how to reach destination will be decided by router. It is a layer 3 device. It understands the IP address and routing thing also. Okay, modems are a modulator and demodulator by name of modem. So it will add a high frequency signal to normal signal. So then we can transmit the signal for longer distances. In our computer modems convert our computer distance network signal into telephone analog signal. Use it to connect internet through the telephone. Guys, I will tell one small thing about a router. Okay, so look at here. Router is a internetworking device. These are a simple LAN networks. This is the LAN. This is also LAN. But this is the hub. I use a switch here. Okay. Next, if you are using a router, that is from communicating from here to here, we don't require a router. To communicate from here to here, we don't require a router if we are in a same room. Okay, if you are connecting these two things together, you can communicate from here to here. So we don't need a router for that one. When you are communicating for a long distance or maybe outside of your network, outside of your private network, you are communicating, you need a router. For example, guys, where is google.com? Is it in your room? Google.com server located somewhere in this world. It can be in a Singapore, it can be in a Bangalore, it can be in a Malaysia, maybe it is can be in a San Jose, it can be in a San Jose only. Okay, it can be in a some New Jersey, maybe your Facebook.com. Facebook.com is also same thing, like it can be anywhere in the world, like that. If you take a server, when you are communicating to a server, the server can be anywhere in this world. So how do you reach? How do you know how do you know how to reach it? How do you know how to reach it? For example, you are in your home. You are in your home. Now you have to go to railway station or a bus stand or airport. How do you know how to reach? You have to reach somewhere, right? You have to go to some place. For example, I want to go to Pune. I want to go to Hyderabad. I want to go to Nagpur. I want to go to Delhi. I want to go to. Don't go to Delhi, guys. Now there is lot of lockdowns are there. Okay, careful. Omicron effect. Okay, I want to go to Kolkata. I want to go to Chennai. How to go? Via. That is also then. I want to go to Delhi. I can go by Hyderabad, or maybe through Chennai, or maybe through Mumbai, or maybe from Madhya Pradesh, right? You can go in a different routes, like I go to Mumbai, Punjab, Gujarat, and then Delhi, and Delhi to Kolkata, Kolkata to Hyderabad, like that also I can go, or directly go to Hyderabad, right? None is me sleeping or all sleeping, no, no. Okay, so how to reach the destination? So who will tell the path to reach the destination? Who will tell the path to destination? The routers use the routing protocols routers or routers, router or a root, anything, router. Okay, router is correct answer. Okay, router, anything. So it will tell the path how to reach the destination. So by, if you want to know how you reach the destination, use the command called a traceRT. TraceRT is a command to know how to reach the destination. So you can see the path. TraceRT command in your CMD and put the server name. Any server, no problem. So we don't have any server with our knowledge now. So we have a common server is google.com. So I'm going to CMD trace RT. Okay, I think I got a IPv6 address. Okay, this is the IPv6 address. It is showing like that because geo. It is trying to find it is trying to reach the destination like this. Finally, I reached the destination. So by 7 step, I think the first step. This is my router's IP address. Okay, this is my router IP address. My router to my geo ISP provider network. ISP provider network. ISP to outside like that. One by one. It go finally it reach the destination. Same goes for a Facebook also. IP address is different. It means it is in a, it's not the same server, right? So it's a facebook.com. Means different server. Means it is a different IP address. Now I'm trying to reach. But if you see the first step, in the first step and second, third also, you can see the data is same almost. Here is the only difference. You can find it's one or two, it's a 120. But later it is changing. See, if you compare, these are a different addresses and these are the different addresses, and it is showing 128 and here it is showing 127. Okay, it took a one more extra step to reach the facebook.com. Okay, this is in a different route. Okay, you can easily understand like if you see I am here, I want to reach here, I can go like this, or maybe this is another path, maybe this is another path, maybe this is another path. So which path is the best path? Based on that, we'll reach the destination. Who will tell the best path? Router and routing protocols. That's it for your devices. Next, we'll see protocols and port numbers. Okay. Next, we'll see protocols and port numbers. A lot of people are dropped. I don't know.